We are live. Hello, hello, and welcome to the MakerCast, episode 26. This is the monthly show where a bunch of makers meet online and talk about their recent projects. And yeah, welcome to all viewers today, whether you're watching live or maybe watching the recording, welcome to the channel. Yeah, so each month the MakerCast is hosted by a different maker, and I am Matou, your first-time maker. First-time host, for today. And of course, the MakerCast wouldn't be the MakerCast if it was just me. So I would like to also welcome with me here in the digital studio, deshipu, Clem, David, Brian, and Timon. How are you doing today?
Great.
Great. Good. Good.
Cool. Good to hear. Great. So I thought, before we jump right into our projects for tonight, maybe we could do a small, quick round of introductions for people watching for the first time or seeing one of us for the first time. So I think I'll start so I can give you a little bit of time to think about what you would like to say, how you would like to introduce yourself. So I'm Matou, tonight's host. I'm from the YouTube channel Matou Makes. I started my YouTube channel sometime last year to motivate myself to finish some of my projects, because I had a lot of projects lying around that I wouldn't finish. And so I started with the intention of monthly uploads, so I had a good incentive to finish some of my projects. And that's going pretty well. Most of my projects have something to do with 3D printing, not all of them, but yeah, most of them. All right, maybe deshipu, how about you? You going next?
Okay, so I'm Radomir Dopieralski. I'm a programmer by day, and by night I need some way to run away from all this programming stuff. So I'm doing hardware hacking, basically. That's it.
Nice. All right, Clem. Hello, Clem, you there?
I think
Yay.
today.
I haven't heard anything because my internet connection is awful as always.
Oh, yeah, that's
So
tradition,
what was the
right?
question?
Your internet connection, that's tradition.
Who
I'm
are
trying
you?
to answer. But yeah, just go on to the next one. My internet connection is awful. I just can't
All right. David, you
really
wanna go
respond
next?
in real time.
Sure. That's a shame about his internet connection, but I live in the middle of nowhere, so I am well familiar with bad internet connections. My name's David. I created the Usagi Electric YouTube channel. I did that last year when, like many people, I found myself in an abundance of spare time. So on my channel, I mostly work with vacuum tubes, except that I'm terrified of high voltage. And saying that I love vacuum tubes, but I'm scared of high voltage is like saying I love cars, but I'm terrified of driving. Those two things generally go hand in hand. But it turns out that I'm nothing if not stubborn. So I found some interesting ways to make vacuum tubes work at really low voltages. So that's what I do on my channel.
Cool, nice. And also, you're you're on the MakerCast for the first time tonight, right? So welcome to the MakerCast.
Yes. Thank you.
Cool that you're here. All right, let's go with Brian. What are you doing?
Hi, my name is Brian Lough. I'm a maker from Ireland. I'm envious of this free time that you talk of. I don't know what that is. I've been making videos on YouTube for about 4 years now, I guess. And I've also been selling on Tindy for 2 or 3 years of that. Yeah, so mainly the projects I work on are around kind of DIY IoT stuff. So I do a lot of work with creating libraries for ESP8266 and ESP32s. And I also really like working with those RGB LED matrix. Basically, anything that I can do to make projects simpler, that's what I like to do. So those RGB LED matrices are just an easier way of like making up displays than creating them out of NeoPixels and stuff. So any shortcut I can take, I'm all over that. That's my style.
That I can relate to that absolutely. Sounds great. All right, and then we have Timon.
Yeah, hi, I'm Timon. I'm mostly stuck on Twitter. I'm interested in hardware, product design, also a bit of art, and I do really anything that interests me. But most of the time, that's PCB design, mechanical design, and manufacturing. I also sometimes do YouTube, but that's been a bit on hold. I think it's been a year since my last video.
Yeah, cool, nice. So welcome you all. I'm not sure if I think Clem's video is, no, it didn't stop. It's still working for me. You want to say something as well? I think his internet connection
I think
is
he's still in parallel universe.
No.
Oh, at least now I can hear you.
That's great.
Okay. Yeah, so you want to say a few words to introduce yourself as well, Clem?
Okay, yeah. Hello, I'm Clem. Maybe you know me from Element 14 Presents, where I do some electronics projects with them and for them. And yeah, every week a new project with me and other makers. And yeah, it's 99% electronics. And yeah, I've been up to a lot of stuff, and I hope to show you some of those. So some sneak peek and some other stuff that is not E14 related. Yeah. Looking forward to that, and to hopefully a stable internet connection.
Let's hope it will stay stable. So I read in the chat that I should boost my audio, my microphone. Do you guys hear me well? Or is
It seems okay for me. It's probably a bit quieter than Timon, just out of comparison.
Oh, am I too loud? Sorry.
No, I don't know.
No.
There's just a bit of a level difference, but it sounds fine to me.
Okay, so chat, let me know if this still doesn't work, and I'll try to figure something out. All right, yeah, well, so we're on the MakerCast, so we also would like to talk about some projects. And I don't know, anyone would like to go first? Anyone itching to talk about their project?
I don't mind going first if you want to.
Go ahead.
Okay, so the two main things that I have been working on, one is maker related and the other is Tindy related, so it's kind of not really maker related, but I think it's kind of fun anyway, so we'll take a look at it. So the first thing is, there a couple of weeks ago I got tagged on Twitter that there's a really big channel called Smarter Every Day, a YouTube channel, and he sent out a tweet saying that he was looking for an internet controlled LED sign, basically, and he was saying that the person who'd be controlling it would be remote from the sign itself, and how could you achieve this? And yeah, so somebody tagged me because, as I was mentioning with those matrix displays, I use them a lot and I do a lot of stuff with IoT projects. And like most of the comments in the chat were like, oh, you could set up a VPN between the two places. And I was like that's a good solution for that, other than it's complicated to set up a VPN if you're not, in that space, probably. And it was probably just more work than it needed to be. So what I did was I said to myself, hey, I could make this in like a couple of hours. So I did. I made it in a couple of hours, and I'm going to show it to you now. And I made a video about it. Wrong thing. Desk plus me has my screen shared. Good job, Brian. Screen share. Let's go back to that and just get rid of the... So you can see a background of that now. Let's see. Here we go. Right. So this is an LED matrix display. It's two of them. so this was the first thing I made, and the message you're seeing on the screen at the moment is actually being sent by someone. I actually don't know. It's either
It's me.
Timon or
I just
Matou.
edited it, yeah.
Yeah. So basically, what it is there's a Telegram bot running on an ESP32, which is connected to these displays. And what the bot is doing is it's just constantly checking for new messages. And when it receives the message, it just displays it onto the screen. So that was actually really straightforward of a project, because I had already done the work with Telegram before. And like the RGB, getting text to display on the RGB matrix is no big deal. So yeah, I made that and it was really straightforward, and I made the video about it. And I notice I'm off camera there. 1 second. Yeah, so I made the video about it, and Destin from Smarter Every Day. I see you must have sent an emoji there. Yeah, we'll get to them in a second, because they're part of the story. So Destin from Smarter Every Day got in touch with me on Twitter and was like, "Hey, I want to use that display for a live stream. Can we sort out like getting it here?" I was like, "Yeah, sure." So I was talking to him a bit, and I was asking him, "Hey, is there any other features that you want?" And he was like, "Oh, maybe if it could support emojis, that'd be really cool." So Timon, could you send it a rocket emoji, please?
Yeah.
And a piece of text after it if you want. So I added some features to it where it could display emojis, but as you could see, you can't find the rocket, is it?
Yeah, wait. I'll find it.
I can send it if you can't find it anyways. So like as you could see, there is no emoji support on the font, because why would there be? So I was like trying to hack together basically how you could display emojis on this without having emoji support. So my webcam is freaking out at this the LED. Yeah, let me just see if I can turn off or configure the video so it's not bouncing the white balance and focus and exposure around, and hopefully that'll help it out. Yes, so as you can see, it supports a lot of rockets at a time. So how the emoji support works is basically, you saw the weird characters that were showing up before. So who knows what you sent there now, but so how it works is, it's basically in the Arduino code, I'm like looking for the emoji characters, and if they're there, I basically replace that with spaces, and then basically kind of tag, hey, where that space was, we're going to draw an image in there instead. So if you want to put some text with the rocket in the middle of it, like it actually fits in fine, as in it's perfectly placed to go along it. And the emoji support part took like a couple of days compared to like the hour that it took to do the full like Telegram text support thing. There's an XKCD comic that this whole thing reminds me of, around a guy like asks a developer, "Hey, we were thinking about making this app where like we tag pictures that are taken in national parks," and the developer's like, "No problem, we'll just use the geolocation contained in the image file." And then the person continues to go and says if it has a picture of a bird in it, and they're like, "Oh, that'll take like 6 months and we need a machine learning team," as in the things that are actually hard to do don't always make sense, to other people. So just to quickly show some of the other features that it has. So we can also support more than one line. I won't type everyone's name out because I'm bad at this. etc. So when that finishes scrolling, it will check again, and I'm after sending it a new message. So if it detects that there's new line characters in the message, it scrolls up to down or whatever, from down to up. What else does it support? I actually kind of forget. There is
This is awesome.
count. I think it's count. Maybe it's countdown. I'm going to quickly, as this is showing up, look at the email that I sent them with the instructions, because that'll be important. Oh yeah, so there's the countdown. So basically, you can send it a number, and it will just do a countdown. So the stream was kind of around sort of like space themes and things like that. So they wanted the countdown for that. They also wanted to be able to put in static. Somebody's trying to get me to drop my database. Bobby drop tables. So if you wanted to display the message right in the center, drop database, that might do some damage to Telegram. It won't do any damage to me anyways. But yeah, so then that's a static text that shows in the middle. And then the last one that I have here is you can do a goal, basically. So actually, I should be able to do... so that's like 80 out of 100. So it's, showing up, basically that there is 80 out of 100. I can't remember if this is the correct format. There we go. Yeah. Yeah. So as you can see there, you can display different emojis, and my webcam is really freaking out at the looks of this. So yeah, so that was that. And that was fine. He used it during the display. It didn't crash, which I was surprised about. It was a 2-hour live stream, and yeah, it went fine. So I see George is asking, does it support mirrored letters? I actually have no idea. It supports whatever the default font is, which I presume is an Adafruit GFX font. So whatever Adafruit GFX supports, it probably supports. I didn't do anything with the fonts whatsoever. But the display he had was 4 of these wide, but I sent him the 4 I had, so I don't have 4 displays wide anymore. I wouldn't be able to fit it on my desk for this picture either. But yeah, I really like these displays. As I was mentioning, they're Hub 75 panels. They're pretty cheap. Like, these ones are about $15. They're 64 pixels by 32. I control it with an ESP32. I'm using a board that I made to drop into it, so like it has all the connections already done, connected back to the ESP32, and it just connects directly into one of these connectors here. But like, you don't need to use that board at all. You can just use DuPont cables or whatever to connect it back up. But yeah, I really like these displays, so I recommend playing around with them. So that was that project, and yeah, I intend to make a follow-up video, because the first video only covered the scrolling text, and I want to talk about the emoji support and things like that. So I just haven't had time in the last few weeks to do it, but yeah, I'll get on to that at some stage. And then the last thing I wanted to show, I'll share my screen. Let me just go back to a picture of me, which is now too high. I really need to fix my... This guy's a professional. Let me share my screen here now. Select a screen. I want to share screen 1 or 2. I don't know. 1. No. 2. Yes. Okay, so Matou, it should be a thing that you can add to the... Yep. Oh, I shared the wrong screen. Sorry. Let me try that again. It's not actually letting me choose. Now it is screen 1. Okay, perfect. Right, so I sell on Tindy, as I was mentioning, and I have this issue where the Irish Postal Service is called An Post, and they do not support bulk uploads of orders. So basically, like most countries, you could format your orders as a CSV and you upload them all and you get the labels out of it. But An Post do not support that whatsoever, and sometimes it can be busy enough with orders, and I did not want to be filling them in manually because it's really error prone as well. So I've written a script using it's a JavaScript. It's normally used for testing. It's called Puppeteer, and I'll just run it here. So what you would normally do with it is like, you want to test the functionality of your web page, that, when this button is clicked, it makes this image appear or whatever. So what this is basically doing is, let me just move it out of the way. So it's going to the appropriate page on Post's website. It's navigating through the options. It's reading the CSV file that I have, and it's inputting all the data from that CSV file. So it's going through it again here. Don't worry, this is fake data. So we're not doxing anybody. And yeah, so it works pretty good. Like, it went through 2 orders there in a few seconds. The last, I did my last 20 Tindy orders with it. I will hit into problems, I'd say, as I do the next 20 or whatever. But yeah, it's working quite well. It's definitely a bit of a time saver. Not really, it's not really a making project, but I just thought it was interesting that it was something that I'd never done, that kind of automation stuff before, and I thought it wasn't too bad. If you're familiar with JavaScript, it wasn't a big learning curve to get up to this point with it, and yeah, I'd recommend it. Yeah. I also don't
help you.
Sorry?
Tools that make your life easier are always pretty cool. Like I really like this. I haven't sold anything so far.
Yeah. So like I don't buy anything with the automation, in terms of like, I only get to this stage, so I can go back and check out like I can go back and verify that the data is okay. And I'd say for the first few weeks, I probably will do that, just double check that the address is what I expect it to be and things like that. But yeah, it's pretty cool. And like one of you mentioned about, like, making your life easier or whatever. I'm hoping, like, so I spent a couple of days at this stage, but I'm hoping, like, over the course of the next like 6 months or whatever, it'll save me a lot of time. So we'll see how that works out, because I guess this is like relatively fragile. Like, if An Post changed their website, I will have to update my scripts too. So we'll see how that works out. But like, it should be relatively robust to, it's not going by pixels or anything. It's addressing basically like, hey, I want this button, look for this button based on its element ID, or, so like if they added more buttons, it wouldn't impact that unless they had the same ID or same identifier that I was using. So yeah, we'll see how it goes. But it was a pretty fun project.
That's awesome.
That looked really cool. Yeah.
Yeah, it's very satisfying to see it like just shoot through the address and stuff and go, wow, this is so much faster than I do this.
Yeah.
But yeah, I still have a bit more to go. Not that part's done, but just kind of like when you check out, basically they send you an email with all the like tracking numbers and stuff, and I'm working on parsing that email out, and the next step would be to actually put the tracking number into Tindy. Now, Tindy don't expose that part of their API either, like updating the tracking number for like customers. So like I could do the same thing on Tindy's site to, automate putting the tracking number there. So that should save a little bit of time too. So we'll see how it goes.
So wait, did I miss it? Do you have that available somewhere?
Yeah, that's on GitHub.
Oh, cool.
It's like that exact thing is not applicable to anybody not using OnPust, that website. But like the project is available to view and do whatever people want with it. But I probably won't make a video, or if I do it, I might put it on my second channel. I like the project so much, I might just do a quick. Basically, do you know what I might do? I might just like cut this part out of the MakerCast and put it on my second channel. You could copyright strike me then too. But yeah, basically just go through the project like that. But yeah.
Yeah, sure.
That's it for me.
Cool. All right. Any more questions for Brian? Doesn't look like it. So I haven't actually thought of in which order we would go. So anyone want to go next?
I can go if no one else wants to.
Sure.
Since it seems my internet is currently not crapping out, I would like to get it over with.
Oh, go ahead.
Yeah, let's do it while your internet works.
Yes. Yeah. So yeah, thanks. Hello. I'd first like to start with the Element 14 related stuff. On the last MakerCast, I showed you the rendering of a Compute Module 4 based thing that I'm about to build, inspired by Timon's Pionora. When I saw that, I thought, hey, I have to do something with the Compute Module. So now it's reality, and it has changed quite a bit. It's a bit bigger, but I have better connections for all the stuff that goes with it, and all of a sudden I'm small. Yeah, it has a bit.
Sorry.
Yeah, I had some clearance issues, so I had to make it a little bit bigger. One thing that I will change in the next revision for sure is that this connector here for the camera, that is the size of the Pi Zero, and I don't like that. I just mixed up the connector, so I want to have the big one in the future. That is not as sturdy as I wanted it to be. And for the HDMI port, I wanted to choose a variant that is a little bit more sturdy than the one that I have. I have already assembled one of these partially, but because of some chip shortages, I have to wait on some more parts. So I don't have everything yet, but I've tried out some of the main stuff. And here's a big spoiler for everybody that wants to do stuff with the Compute Module 4. If you populate the Hirose connectors, the dots go on the bottom, okay? So when you want to build something like this, the dots on this little connectors go down.
Sounds like you had some issues with that, or?
No, I have done it perfectly the first time, but that is a point that is missing in the documentation.
Oh, okay.
Nobody tells you how to orient those. And they seem to be symmetrical, but they aren't. But it has to go down. That's the right way. Yeah, I've put a lot of this stuff on. I haven't started it yet. But I can show you something like the thing that it should drive in the end, or parts of it. So this is as you can see, a 4-jaw chuck. And this is the 4th axis for the CNC machine that this thing will go in. But it's a bit unconventional. So I use like a big gantry that has X and Y and Z, of course. And then I don't put one of these, I put two of them and like a fingermajig in the middle. So you put your work on that and you can rotate it while you're machining. So basically you can flip your work around and machine the other side, because I hate refinding the other side of your work when you do double-sided machining. And that machine should be able to do that like on its own or without having to reload the machine, so you don't lose the coordinates. So that is the idea behind it, and it's pretty huge. I'm now doing an experiment, and I try to move my camera so you can actually see it. Okay, no, I can't do that. The cable is already too short. Sorry, but it's like big, like a meter by 80 or something like that. It's a huge machine, and that's because that's the idea behind the board, that you basically have the computer and the CNC controller that you usually have with a CNC in one board. So you can use that to drive a 3D printer or even a pick and place if you want, but it's actually more made for CNC. And after I have finished that one, I have received some RP2040 samples, and now I want to do a version that uses the RP2040 as a coprocessor. So yeah, I pretty much have to do another revision. And that's a video coming up on Element 14 someday, when I get.
I was just going to ask you whether this will be a video, because this looks really awesome. It's a bit out of my league, I think, but this looks super interesting.
It's a lot more simple than you can think. It really is.
Cool.
There's nothing that special about it. It's basically putting Legos together. But I think for the video, it will be mostly about design considerations and how to get stuff like that together. And maybe I have also built a little laser cutter. It's a meter by 50 centimeters, I think, or 80 centimeters. It's like
a little laser cutter, yeah.
A laser engraver. It should be able to cut like thin material, but it's more like an engraver. And I think I will put that in the video. But that's like a few months out, because videos have to be made before they get published. So that's on the table, but nothing done yet. So I'm like in the middle of stuff. I need to wait on some parts and then onward. And I hope this thing works like it should. And then the other thing that the non-Element 14 stuff. Last time I told you, hey, I made this little development kit that I showed on the last thing. I've made a clip for it. And I've made some of them, and they will go up on Tindy. And here's also something handy if you want to have a really nice background that you can later in post easily change. Use a piece of leather, because leather looks awesome on camera and has some structure. So it's not like plain color, but it's very easy to film because it doesn't like to reflect that much. And I just got a packet of like leather offcuts in a few colors, and that worked really good. And in the video, it looks pretty much purple-ish, but that's just gray leather with light. And with color grading, you can pretty much make a gray thing into everything else you want. So yeah, those will go up on Tindy. I don't know yet when. Actually, I wanted to have like, now it's live, but Tindy doesn't work like that. But hopefully I will get that out soon. But before I can make that one live, I have to put a lot of other stuff on there, because I'm, as I told before, I'm starting a little shop with stuff that makers need and want, and mostly stuff that you can't get at all the other places, because everybody sells Arduinos and chips and batteries and stuff, but none of them sell things that you may need for a weirder project or that you just can't get anymore. And if you're doing some like headphone project, you may want to go to my homepage and pick up one of these headphones from the 30s, and they work. Yeah.
Awesome.
So the big difference is a lot of people sell you like old stuff, but they usually don't repair or test those things. So I make separate listings for broken stuff that you need to fix, or tested stuff that already works, or stuff where I've already put out the dangerous stuff and you only get the functional parts, or you don't get the rotten cables, you only get the innards that you want. And you get this stuff and things like that. That's what is that? Yeah. It has the coolest mechanism in the world. And then it goes like that. And then you put that out.
That looks
here,
like such a satisfying mechanism, actually.
It's like a movie almost.
You can just get this thing just for the satisfying mechanism. That's German precision engineering. That's
Nice.
a tube and the matching socket that was in a tank. So that was was built into the control system of a tank, and it was also used in planes, warplanes.
They make also like
So that's pretty awesome.
revolving version of that. Did they make
I
a
couldn't understand you.
revolver version of this, so you could really switch fast?
Oh, they make. Oh, yeah, that is already for like a quick change. So you just pop it open. There's a little screw on the top. You have a little handle. Screw that in. Pop it out. Put the next one in. Screw again, and you're ready to take off. So that's already for things. I have stuff like this. That's a tungsten thing that runs at 800 volts. Pretty neat. More like a desk piece, but also functional stuff. And if you ever wanted to know, you know that conspiracy that that light bulbs are made to fail quickly, and that's pretty much. Oh, there's my countdown. That's pretty much true, because I've got one of those here. That's one that doesn't have a Wolfram filament. That's one of the really old light bulbs with carbon filament in there, and it's intact. That thing works. So that's one. Like if you heard the stories about the light bulb that is like running for 100 years, that's pretty much that model. And also a thing, I've recently binge watched David's channel for tube content, like hours of stuff. And then the YouTube algorithm got really biased and recommended a video of a tube collection in America. And I watched through that. And then he talked about the tubes that were used in television cameras to capture the image. And it's really highly specialized tubes. They were like the size of my head in the beginning. And the electron gun just like activates a phosphor, and then they scan whatever lights up on there, and that correlates with the picture, and then you can turn that into electrical signals. It's pretty complicated, and I've got one of those. And here's an electron gun on this side, and here's like a phosphor screen. And this is pretty much a late model. In a color TV camera, you had 3 of those and a 4th one for the luminance signal. And that is how TV cameras worked in the early days. And then it pretty much got directly over to image sensors that we know today. That's pretty awesome. So I put stuff like that in, and you can still play with these, so they are functional.
Wait, so this was instead of the sensor, or?
This was the sensor.
This was the sensor, yeah.
This was
of course,
pretty much
yeah,
the
because
sensor,
there was
yeah.
no
But just
sensor
for
thing.
one type of signal. So you need to filter it to get another color. Basically, you put a filter in front of it, and that's for one of those, and
Like
that's for the other one.
Either P,
Yeah.
but in reverse.
Pretty much, yeah. Pretty much, yeah. And it's really fascinating how these things work. And after watching a lot of tube content and a lot of going through my collection, I realized that you can use a lot of these things for a lot of awesome projects. At least I got like telephone parts, like the cling-a-ling mechanism, and a lot of other vintage stuff that you just can't find that well, or you wouldn't buy that for a project if you didn't know it was working. It's just too much risk. You can just buy a lot of stuff and you wouldn't find the thing that you really need, and you don't have storage space. So I'm pretty good at finding weird stuff online and on flea markets, and and I try to bring them in a form that makers could use. For example, I have 100 microphones from taxis, and I pretty much gutted all the rotten parts out of that. So if you have like a project where you need a little hand microphone, I've got that. But everything is in development for the actual shop. But I hope that I can supply a lot of makers with awesome parts that you can find anywhere. And I also want to make some kind of like surprise boxes where I just have a box that costs like €5, and then there's something weird in there, or something useful, and not just a box of resistors. Yeah, that's pretty much from me.
Projects in mind for those parts?
I want to build something that David will show us. Probably everything that David shows on his channel.
All right, well, I have a question. I have my own Discord that I've been chatting with people, and they absolutely love CRTs on there. And one of the types of CRTs that we've recently become very obsessed with is called a Williams tube. I don't know if you've ever heard of this, but vintage computing back in the 40s and 50s, before core memory became popular, how to handle random access memory was like all over the board. And there were a bunch of different types of memory that were being tested. Delay line was quite popular, but Williams tubes also had some form of popularity. And there's essentially a CRT, a cathode ray tube, with a mesh on the front that detects negative charge wells wherever the beam strikes. And then it has a loop, and that's how it stores memory. It's detecting, if the beam is striking, that's creating a negative charge well, and then that's a 1. If the beam is not striking, that's a 0 or something like that. But we've had a bear of a time trying to figure out all of the control. We've had a bear of a time trying to figure out all the control for how it would handle that. But we've also just been shopping for Williams tubes, and they're incredibly rare. So have you ever come across a Williams tube?
I may have one. I'm not sure if it is one. Yeah, that was the most crazy thing ever. When I saw that museum video, he said, "Oh yeah, and this is extremely rare. I have one of these tubes from early TV broadcasting cameras. Hey, I've got one of those." Is that really so rare? And then I've watched something about, like, a friend of mine was unboxing a tube collection he bought, and in there was a Napfröhre, which is a very odd type of German tube that was only used in one device. The device is called Kleinfunksprecher K. It's like a little radio transmitter. One device. So the tubes are extremely rare. Guess who has 2 of them? And I had no idea what they were. Like, oh, that is odd. I keep that. And so, and I think I have something that has like a grid on the. I couldn't tell you if it's that. I will look it up.
Yeah, definitely.
I have a lot of stuff that I couldn't identify yet, and that's one of the things that is keeping this whole process pretty much in the air. Is I have to identify and check stuff. So I have planned to build my own tube tester from a kit. Or it's not really a kit. So you buy the plans and then you have to build everything else. It's pretty expensive and pretty intricate, but I really want to test everything that I sell beforehand. So everybody, I don't have a large house, Maiko. I have a very small basement, and and pretty much everything is stuffed with stuff. But it's also, if you collect small things, it's not that you don't need that much space. So I'm picking up a lot of, I think 200 items for the thing tomorrow morning. So that would also be awesome. So I hope to supply some stuff to your enthusiasts on your Discord. Maybe we can find something that is rare or interesting for a video.
Yeah, excellent. That would be awesome.
So that's basically a question to everybody, especially chat. If there is some weird oddity you would like to have for a project, let me know, and maybe we can find that one.
Clem is the oddity specialist for that.
That's a good tool to have in your pocket. An oddity specialist.
Absolutely. Yeah.
I think maybe BitLooney found my Telegram bot. I don't know who's messaging this anymore, but it's not me. I swear.
Yeah, I like this. We have nice messages here. Let's make them larger for a moment.
I'd make it available to the public, but I don't trust the public whatsoever. Yeah, but I think BitLooney has it. Or
not a good
Clem. Very nice. All right.
So who's next?
Well, Clem, do you have anything else for us? That from you? Okay, cool. Any questions for Clem? So since we're on the topic of cubes...
No, that's pretty much it.
I have a question.
Yeah.
So about this large truck that you showed us that goes on a CNC, it makes me think about those egg engraving machines that you can build with a stepper motor and a servo. I keep on thinking that on this CNC you could have like a billiard ball engraving machine instead.
I think that's a good idea.
I think it was a good idea that Clem's internet has collapsed under the weight of the amazingness of it.
He has entered the parallel universe once again.
He's blinking though.
It's not gone. I think it's just a long delay.
Maybe he's pretending.
Yeah, I just don't want to interact with that idea. Or maybe it's an upcoming Element 14 video idea that he can't talk about. That's what I'm going with.
I thought I was done.
Nice. All right. Shall we stay with the tubes? I don't know. David, would you like to go next?
Sure, yeah, I'll go. Since Clem's got us on the topic of vacuum tubes, that's essentially my whole world for the last months. As I said in the intro, I'm deathly afraid of high voltage because I'm kind of dumb and accident prone, so I tend to stick my fingers in the middle of circuits that are live. And if there was 600 to 800 volts in there, that could lead to a bad day. So I'm nothing if not stubborn. So I kind of settled on some low voltages. So I do pretty much everything at 24 volts. And then vacuum tubes often need a negative bias voltage. So I have a negative 12 volts as well. So at worst case scenario on any of the circuits that I build, there's a maximum of 36 volts of potential difference. So it's they're all incredibly safe. And a lot of people don't think that vacuum tubes can operate at low voltages. But it turns out that most vacuum tubes operate really just as they would at high voltages. You're just limited in the amount of gain you can get. Now, the second aspect of what I do that makes that actually feasible is that I'm deaf in one ear, so I'm not a very big audiophile. I can't tell you the difference between a fantastic amp and a good amp. So audio amps all sound the same to me, kind of. But where I am really interested in is very early computing. And so when you're doing computing, we're kind of forcing these essentially analog components to operate in a digital manner. And so what I'm doing is I'm forcing a vacuum tube to either go into saturation or cutoff, where it's either transmitting or it's conducting as many electrons as possible, or it's not conducting any electrons at all. And so from there, I can design different circuits, and we'll see if I can get the camera to work here. I got a couple of my projects set up here. We'll see if you guys can see this. There we go. Okay, I think you guys can see that. So I'll turn the power on, and it may cut out. I'm not really sure. Yeah. Okay. All right. There we go. Okay, so this first, I got a couple projects that we'll show, but this one right here up front is kind of my first proof of concept that I built for the main large project that I'm working on. And the main large project that I'm working on is a replica of a 1-bit microcontroller. And that sounds really weird to have a 1-bit data bus, essentially, because everybody thinks of the 2502, which has an 8-bit data bus. But when we're talking about vacuum tubes, you got to boil everything down to as minimal as possible because they start taking up a colossal amount of space. So this first project is set up where we have a logic unit over here, we have a result register over here, and then we have a little input over here on the right. And I can input different instructions. So you can see this is 101, and that's the instruction that's being input. And over here, if I look, that's an OR with the complement of the result register. So whatever data is stored in the result register is one operand, and then the other operand comes from the data, which is this additional switch here. And then whatever input I have set here, whenever I hit the clock, the new result will be stored in the accumulating result register over here. So if we do that, my VFD is a little dim, but it stored a 1 right here. So now we have a 1 stored in our result register. And then I can hit it again, and that 1 goes away. So this was like a really small proof of concept for the bigger version that we're making. So the instruction is just 3 switches, and ultimately I need it to be a 4-bit instruction, and that instruction also needs to be stored in its own register. The logic unit is minimized here because we only got 3 instructions as opposed to 4 instructions. The result register didn't work very well, so that's been completely redesigned. So there's a lot of very interesting aspects going on. We also don't have an input and output enable registers as well. But this was, as I said, just a proof of concept. And that led into, we'll turn the power on for that one as well. And this is where we're going to start getting to a bit of spoilers here. So I don't know if you guys can see this monstrosity over here. That is 30 plus vacuum tubes of insanity and a couple of days worth of work. So essentially what we have is we have 4 D-type flip-flops in a row here. So this is the instruction register. And then we have some buffers here to buffer the output. And I don't think my terrible webcam here is going to pick it up, but there's also 4 little vacuum fluorescent displays that will show me what is being stored in the instruction register. So 4D flip-flops means that it's a 4-bit register. So this can store a 4-bit binary number for us. And so right now, let's set all these to off. So if I hit the clock right now, it's storing 0000, and then I can put the switches here and then toggle the clock, and then it'll store 4 ones or whatever. So that's just like the first step of the ultimate thing that we're building. So that, like I said, is like 30 plus tube. I think it's like 32 tubes. And then ultimately doing the mental math, it's going to come out to like over 200 tubes. So we've got a long ways to go. And we have some thinking to do about power supply when we get there, because even though I'm at low volts, it's going to need a lot of amps to run things. And then while that's like a long-term project, so while we're working on that, there's another one that I've been working on kind of quietly in the background, and that's this interesting collection that you can see here with the 2 boards that are standing vertically coming out of my breadboard. And again, a lot of people will see vacuum tubes stabbed into a breadboard and they'll panic and they'll go, "My God, what are you doing?" So I just want to reiterate, there's only 36 volts, and 36 volts maximum potential difference on a breadboard is like nothing. It really, I've had over 150 volts through a breadboard before and haven't had any problems. Not that I would recommend doing that. But so what we have on the breadboard here is these two boards that are standing vertically are operational amplifiers. So there's two separate operational amplifiers going on here. And they're set up essentially as a long-tailed pair with 3 amplifying stages and then a cathode follower buffer to give us a low impedance output. I realize that I may be throwing out a lot of jargon, but we'll just run with it. And then in the bottom left here, we have an SR flip-flop, and then we have a cathode follower buffer for an output, and then we have a drain tube or a discharge tube. And so people that are familiar with their integrated circuits, if they hear 2 operational amplifiers and SR flip-flop, that sounds an awful lot like a 555 timer. And that is essentially what this is. It's a 555 timer. It's the worst 555 timer in the world. And I don't know if you can see it. I've got a little vacuum fluorescent display here that's blinking. And I've got a little knob here so I can slow that down or I can speed that up quite a bit. And so right now, this 555 timer is set up in A-stable mode. So it's an oscillator. And if you want to make an oscillator out of vacuum tubes, doing it with this many tubes is dumb. There's a lot better ways to make oscillators. But I've tested this in both A-stable, bistable, monostable, and as your Schmidt trigger. So the 4 primary functions that you can use a 555 timer for, this will do. And so that'll lead me, I'll switch back to my regular camera here. And that kind of leads me nicely into this next step here. Okay, so I think you guys can see me. So you saw the breadboard version of it. And so I spent the last couple of days actually, specifically for this, not MakerCast, spoiler cast is what I'm going to call it, because I'm spoiling like the next 5 episodes. But I essentially built this, which is, you can see it's got 8 nails. This is my early prototype. But this is, a very large, terrible 555 timer. It's got 18 6AU6 pentodes on it. The reason I'm using the 6AU6 pentode is because they work incredibly well at low voltage. Wait, that's a 555 timer. It makes the 555 passive kit look rubbish. Yeah, sure. So it definitely looks cool. And I actually fired this one up yesterday and tested it, and it does work. So the design, my PCB design, did work with minimal bodge wires. So if you can design a PCB, print it, and get it working with like 1 or 2 bodge wires, that's a total win. Because anybody that's designed PCBs know that you often have to make like 4, and then it still requires bodge wires.
I find 3 is the magic number for me. The first 2 are just a write-off.
Yeah. That's how it comes down. But I was like, I had to work really hard because like I cut this PCB on we have a Bridgeport Easy Track CNC 3-axis mill outside, which is overkill. That's like hacking a nail in with a rocket launcher. It's way too big for cutting PCBs, but it does all right. So it's a single-sided PCB, but this took like 4.5 hours to cut because it's quite a large PCB. I mean, you can see it's like the size of my face. So I'm kind of an impatient person, and I don't want to cut 2 more 5-hour cuts. But I'm quite happy that I did it right. And so it's 18 6AU6s. The 6AU6 is like really dirt cheap. I've been lucky enough to find a couple collections of them on eBay for like really cheap. It comes down to like 20 cents a tube. And so that's why I'm using the 6AU6. It's the best low voltage tube for the cheapest that I've found. I could, if I bumped up the voltage, like if I had probably just 100 volts and maybe like a minus 50 volt negative bias, probably cut the tube count down considerably, especially if I started using dual triodes. So a pentode has essentially 5 active elements in it. It's got a plate, a cathode, and then 3 grids. And so it's control grid, screen grid, and then suppressor grid. And the screen grid and suppressor grid are really there just to help the tube perform better. They don't really offer any additional control. So it's best to think of, one pinto as being essentially one switch. It would be like the equivalent of one field effect transistor or something like that. But a dual triode doesn't have the screen grid or the rest of it, but it has 2 plates, 2 cathodes, and 2 control grids. So it's essentially like 2 switches inside a package that's almost the same size. These are 7-pin. They're just a little bit fatter, and they're 9-pin packages. And those are really popular for audio tubes. But because you can get 2 essentially switches within one tube, you can right off the bat, you can cut from 18 tubes down to 9 tubes. And then I said, my operational amplifiers have essentially a differential pair and then 3 amplifier stages and then a cathode follower buffer. But if I had more voltage, I wouldn't need that many amplifier stages. So I could probably get each operational amplifier down to just essentially 4 switches. And then that can be compressed down into 2 dual triodes. So that could be, 4 dual triodes for the 2 operational amplifiers, and then maybe another 2 triodes up here. So you could theoretically compress it down considerably from this monstrosity to like 6 tubes. But it doesn't look as cool as having 3 rows of 6 tubes to make 18 tubes, because this looks epic. And you can see even like
Tell us again the part number. What is the tube called?
This is a 6AU6. It's just a small signal pinto. They were really, really popular in the United States in like TVs, because in the late 50s, TVs were all still vacuum tubes, but there was a big economic boom, so everybody and their dog had to have a TV. So they had to create these small signal pintodes in massive quantities. So there's a whole lot of these out there. Now there's another small signal tube called a 6CB6, and I have about 200 of those in a bag over there as well. But I have trouble getting them to do the low voltage trickery that I want my vacuum tubes to do. And so the 6AU6 seems to work the best. Now, that's not to say that the 6CB6 can't be done. I've actually plugged the 6CB6 into my operational amplifier and gotten them to work, but you need to tweak some resistor values, and the tolerances change a little bit. So all in all, I think you could probably get just about any vacuum tube you can get your hands on to do what you want to do. But the trick is that the circuit has to be completely designed around the characteristics of that tube. And since I've done most of my research and testing with the 6AU6, I'm really familiar with how they operate. So that's my go-to tube. But I understand that like in Europe, the 6AU6 is really hard to find because there was a different small signal pintode that was really popular over there as opposed to this.
Yeah, but it's pretty commonly available because it's used in a lot of amps. So you can get them, but they're not as cheap. So 1-2 euros is a usual price for those.
Yeah. And so like I said, with the vacuum tube computer, I'm looking at like 200 plus tubes for a 1-bit microprocessor that doesn't even have any memory on it. And so like when we're talking about really excessively large scales like that, the price of the tube starts to become incredibly important. Like if I can find the tubes for 30 cents as opposed to 40 cents, like I'm going to buy 30-cent ones because they start to add up very, very quickly. So there's a bit of trying to compress the designs down as small as possible, or just get cheaper tubes and live with a big design. And so I went with the cheaper tubes and the big design. So, but anyways, about this 555 monstrosity that I built here, aside from the fact that I just think it's really cool to have a vacuum version of an integrated circuit chip, I forgot what it's called, the very big 555 or whatever the name of it was, where it was made with individual transistors, discrete transistors, was kind of an inspiration for this. And so I would actually like to further develop this into a kit that could potentially be sold. I collect up some tubes, I collect up some sockets, and then I get the boards professionally made instead of cutting them on the mill. And then I got to come up with something better with the pins, because just having nails is not the the greatest design choice. But I think that might be something that people might be interested in, even though it would be quite expensive just from a materials cost standpoint. Because 18 tubes at 30 cents a tube, that's a good chunk of just the cost right there. And then the sockets are going to come in at like $1 a socket, so that's $20 just for sockets. But I think a low quantity kit of these would be kind of fun. So that's something that I may lean on the maker community, because I've never made a kit. I've never even sold anything. I have like 8 cars because I keep buying stuff and not selling things. So I don't actually know how to sell something.
I think you'd be surprised.
So would something like...
Put me on the list.
Yeah, I think you'd be surprised with the demand for something like that. There's another guy from Ireland, Part Fusion, and he sells like a giant LED on Tindy, and like I'm pretty sure it was pretty popular. Like, it's literally just an LED. I'm tiny here, but like the LED is maybe like 1.5 feet long, or it's huge. I'm still really small, sorry. Yeah, like he like casts it in like some mold or whatever, and has like 2 copper or 2 I don't know, 2 pipes coming out of it, and like they're $70 or $80, but like they're completely unique. Like, as in, if you want something cool and unique, people will pay for that stuff. Like, so I could definitely see a big demand. But Looney thinks they'll sell out within 3 seconds. I think he picked that number just for me to pronounce it, maybe. Yeah, I think you'd be surprised. I would definitely, because it would be relatively expensive, I think it'd be good to do some form of like, you'll know yourself. The people in your Discord and stuff will, talk about, how much, they'd want to get it or whatever, especially if you can give a ballpark price. But yeah, it's selling stuff is definitely it's a big challenge, but it's fun.
Yeah, and I did talk with the people in the Discord. We did like some quick numbers, and I'm pretty sure I could do it for like less than $100 per kit. Which is like super expensive, but I mean, that's 70% of that, 80% of that is materials cost. Because like, unless I'm doing 150 boards, like the boards are quite expensive because they're quite large. And then, there's something like 200 or 150 resistors or something like that on there. But I mean, there's not a single semiconductor anywhere on there. Like in my big vacuum tube designs, I use, small signal diodes to simplify things instead of using like the 6AL5 dual diode, because I didn't want to have 500 tubes. I wanted 200 tubes. But on the 555, there's enough analog componentry to it, like the op amps are just purely analog, that I didn't need to use any diodes anywhere. So there's like not a single bit of silicon. So to have a completely silicon-free 555, I think is a pretty unique thing.
Perfect for allergics.
I'm sorry, what was that?
If you have a silicon allergy, that's perfect for you.
Yeah. I mean, excluding the silica in the glass, but...
Based on my own experience with selling stuff, if you can make a kit for $100, then you should sell it for $300.
I think the $100. Yeah, I think if $70 or $80 of that is like component cost, is probably too cheap. But we can talk about it in the Discord, actually, if you know. Yeah. It's probably not a great conversation for this, but I think it's probably too cheap. I would agree with deshipu 100% on that.
Like, I don't sell anything. Like you walk out to the garage and there's literally 10 cars in the garage right now, because I just I still have the car that I had when I was fresh out of high school, which was like 20 years ago.
Yeah, selling things, especially if you want to make it sustainable. People often underappreciate how much difference there is between actually making it for selling and just making it for yourself to just make one.
Yeah.
And you really need this 2 tiers of extra margin for for shipping, for like returns, support, packaging, and then if you want other like shops to sell it, they want to have their own margin, but they don't want to have a higher price.
Yeah. Well, I mean, like the
Welcome
purpose
to the
of it would
business
not be
cast.
to be a business. The purpose of it would be to get vacuum tubes into more people's hands, because the more people that are interested in vacuum tubes and keeping this technology alive is, I think, a win for everybody.
Cool. Nice. All right.
Yeah. So that's my vacuum tube life.
Thanks very much. Yeah, awesome YouTube channel. Go watch David's channel. That's pretty cool. Okay, who would like to talk about their projects next? 2 people waiting still.
I can go.
I can do that.
Thank you. Then go ahead.
So, okay. So I'm going to talk about one of my older projects, but more successful ones. So as I mentioned, I'm a programmer. I'm actually a Python programmer. I program with Python. And being a part of Python community, I also sometimes, like before the plug at least, run workshop to teach other people to program with Python. And one huge problem with those workshops is that people will come with random computers they have at home, usually laptops. And those computers have like all possible things installed on them, like in the sense of operating systems and editors and whatever. And then if you want to teach them to program with Python, you have to spend like half an hour to make them install Python on that computer, make them install your editor of choice on the computer because they would insist on writing it in Word. And then half of them will not have administrator password for the computer. For others, they will have like the newest macOS beta version that doesn't support Python yet, or whatever, doesn't have the things that you need. And then there is an additional complication for me because I like to teach by games. Computer games are a great way of motivating people to teach themselves programming. And that means you need some kind of a game library. And game libraries for Python are usually binary. So that's also a complication. You need a special installer, you need additional rights, so on, so on. So you can easily spend 1 hour of a workshop just getting all the computers to work. And then when you finish the workshop, people have their games on their computer. And that's it. They can't even send it to a friend to show them what they made, because that friend would have to install Python, install everything, and so on. And that's way too complicated. That's why I thought maybe there would be some way of having a dedicated device that you just connect to your computer, and you just program your game. And then you disconnect it and show it to whoever you want. And zero setup needed. So I started with this thing that it's called Pew Pew Wing, because it's for the Adafruit the wing. Yeah. And I basically made this shield for it that only has an 8x8 LED display and some buttons on it. And that worked surprisingly well. The main problem I had with it is that, the feather back then costs like $30. The shield would cost at least 10, because, as I said before, if I can produce it for $5, then I have to sell it for 10 because that's the reality of selling anything online. And it adds up pretty quickly. If you want to add the battery, there is a battery inside here. Yeah, you can see it. Then it's $50 easily. And that's a little bit of a problem because I don't like to make workshops for rich children. I like to make workshops for all the children, not just the rich ones. So I sat down and redesigned it. I basically took the schematics that Adafruit has published of their feather, and I just deleted everything from it until as long as it worked, and got down to something like this, which is the same thing, except it has the feather already under the display, at least what's left of it, which is basically just the SAMD21 chip and 2 capacitors. So I got it down to very few elements. And of course, all the buttons and the battery holder. I switched from powering it from USB to powering it from battery, because it turns out that on just 2 AA batteries, it can run for 8 hours straight. And I can't do workshops that are so long, so that's fine for me. And because it uses CircuitPython, which is Adafruit's version of MicroPython, when you connect it to the computer, it comes as a USB drive. So basically, you just edit a code.py file on this USB drive with an editor you want, though the Mu editor is preferred. And then it just works, right? When you save, it restarts. So you make any changes and save, and then you can see your code running on it. I have one running here, I think. So yeah, then I made a bigger version, and for several different events, because people wanted to use this as a conference badge. And CircuitPython is very nice for conference badge. That was EuroPython 2019. This was Noc Informatyka, as a Polish event. It's a very nice thing because you don't need to install a compiler on your. So yeah, it's playing Snake.
What display is that one, deshipu?
So those are all LED matrices, 8x8. The very first one that I made, I got my hands on a bicolor matrix. So it has green and red LEDs. So I had 4 colors in there, because you can get 4 combinations, right? Black, green, red, and yellow. And then when I switched to the cheaper version, I noticed that the single color, the monochrome matrices are much cheaper. So I rewrote the code to use PWM to basically have 4 shades of whatever color the matrix is. So
and is that one expensive? Like, what's the component cost of the screen?
I think it's about $7, the big one.
The entire board, or just the matrix?
Oh no! So this particular one for EuroPython.
Yeah.
I think the end results, we made like 1,200 of them. And at that number of boards, it was like €8 a board or something like that, without the batteries.
Yeah.
So it's reasonably cheap. Those you can, advertisements, you can buy them at Maker Fabs for $10 a piece. Without the batteries.
Nice.
Cool.
So yeah, I got them as cheap as I could, and $10 I think is reasonable price for a workshop, especially if you walk out with a game that you made yourself.
I'm definitely gonna
only 8x8
add one. Sorry.
So it's super easy to program. it's not scary to people. People look at it. Okay, snake. I could do that, and that's super important because that's the main barrier for people from learning programming. It seems like there is this myth that it's only super smart people can program, and you have to be this smart to enter, and so on. That's completely untrue. And you have to be stubborn, basically. That's the only requirement.
And the proof you don't have to be smart to program.
Yeah. So that's basically like the overview of this program. And now the new thing that I made is this version of it, which is basically when Sion, the ultimate unexpected maker, made his game play sheet for his board. I noticed he used touch input for the buttons, and then I thought, okay, I could do that as well. SAMD21 has touch, so it has exactly 6 touch pins that you can use. So that's perfect for my use case. And I thought, okay, so that makes the board very flat. So what else I could remove to make it even more flat? Obviously, you don't have to use the LED matrix. You can use discrete LEDs. I did that, and I went back to the bicolor ones. So if I can zoom in, yeah, those are 4-pin components. Those are there are 2 LEDs in each of the squares, basically. And they are connected in opposite directions. So I basically have 2 displays, one way, the other way, and I alternate between them when displaying. One is one color, the other is another color, and they use the same pins. So that's nice because there are diodes, so you can do trigger like this. And I also removed the USB connector and use this. Can you focus? Yeah. So this is basically a 0.6 millimeter PCB with a cutout. So you can do. You can basically connect it. Am I doing it right? Yeah. You can connect it to a micro USB socket like this, and that's a super cheap USB socket that you can use, and more importantly for me, it's super flat. So basically I have a business card sized game. I can so Tetris.
That's awesome. That's really cool.
Yeah, basically, and there are colors. So this is what I got working in January. And the next step for this is several refinements. So first thing, I'm going to make it this size because this is too small. Basically, the touchpads for the arrows are too close together, and you cannot comfortably play on this. Also, the display is way too small, so I need to space the LEDs more. Yeah. The other thing I want to do is to move all the components on the other side, including the LEDs. That's why, Brian, I was asking you about the reverse-mounted LEDs that you were researching, because I can basically make square holes in the solder mask and mount the LEDs on the other side. And this time I would use normal monochrome ones with the grayscale thing. And that would actually, because this board is not cheaper than this board. Let's be honest. Using a single component for the display saves a lot of money, because you pay basically by soldering point when you pay for assembly. Mm-hmm. And this is 64 LEDs. That's 128. If they were monochrome, that's 128. They are actually bicolor, so that's 256.
Yeah, so it's funny with the assembly. especially with say like through hole parts, like as in, you know, if you want to get them to solder down like a ribbon cable which has like 12 points, that costs like 12 times, you know, which is the same as like 6 through hole resistors. And like
Right.
you'd much prefer to solder the ribbon cable because you just like put a bit of flux down and, you know, run it along than the 6 resistors. But yeah, no, that's really interesting. I even though I'm involved in it, I wouldn't have immediately thought that was the same price as the other one.
Yeah, and this matrix is basically just I can't show. Maybe I can show here. It's through hole thing, so you can even leave it for people to solder. Like the first kit I did with this was unsoldered, so the matrix you would solder yourself. I had problems with that because people would buy this and then complain that the display is very, very unreliable because they didn't solder it. I was surprised it worked at all, but yeah. Anyways, so that's the basic idea for this. And there is one more project I'm working on right now that is related to this as well. Because at some point I decided, okay, so if a single component is cheaper than 64 LEDs, then maybe just using a TFT display will be actually, you know, cheaper, even if you display like huge squares on it. And I made this thingy, which is the Pew Pew M4. So those are basically called all Pew Pew. Pew Pew standalone, Pew Pew featherwing, whatever. This is Pew Pew M4 because it has the SAMD 51 M4 arm on it, but it also has like regular display. And it comes with a preloaded library on it that does exactly the same thing as here. So basically, let me switch it on. Yeah. So basically, you can play the same Tetris game. You can basically write the same code and it will run simulating the LEDs, basically.
That's cool.
But you can also, let me just reset it. You can also make like games like this, which are a bit more ambitious, like Space Invaders and so on. So that also was like 2 years ago before the plug thing. But now that you know, we have this nice little guy called Raspberry Pi Pico. And I thought, okay, it comes with a lot of memory on board. So the problem with this is that you have very little memory and you need to put all your graphics or the pixels in your RAM when you're loading them to display them on the display. So a lot of memory helps. It has a flash chip on it, which helps a lot as well. And it comes with a boost converter for the battery power. So that also helps. So I thought, okay, I need to make a version of this, but a little bit better. And I started prototyping. And I also figured out, okay, I can use a little bit bigger display this time. Because, so the problem with, I use this display because it's cheap. And second, it has like physically largest pixels I could find. It has the largest diagonal with the smallest resolution that I could find. And this is important because you are basically sending those pixels over SPI bus at 40 megahertz clock. So if you want to have any reasonable frame rate on your game, you need to send as little of those pixels as you can. So you want low resolution. But you know, with those displays, I could get one that has that uses parallel instead of SPI, parallel bus. And then because the Raspberry Pi has so many pins, I can easily drive that display without any problems. And using the PO peripherals, I can do this really, really fast. So that means I can use a display that is 320 by 240 instead of the twice as little one from here. And so I have I have a prototype so far, but it has a very low frame rate for now. You have to paint it yourself, basically. For a comparison, as you can see, it has much bigger display. I want to use a real speaker this time, and I have the here potentiometer for volume control, even so super deluxe edition. I'm still considering what battery to use right now. If it's a LiPo battery or if I should just do like 3 AAA batteries, and so on. So that's like work in progress right now.
How will you mount the Pico to the board? Is it a solder thing?
Yeah, I'm thinking I will have pads in there because Pico has castellated edges, so that makes it easy to just put it on, align put like toothpicks into the holes, so it's super aligned, and just drag solder it or whatever, or just solder it one by one. Should be easier than through hole, actually.
I'd love if Raspberry Pi came out with a socket for it, right? Like, wouldn't it be nice if there was a cheap socket part that you could add to your board and it would just clip in, right? As in...
Right. Well, you can use like female sockets. I actually use that like pin headers.
Yeah, but even, like it would be much flatter if you didn't do, regular female pin headers.
I have like 2 millimeter female headers.
Oh, nice. Yeah, I was kind of thinking more of like it like kind of clamps in, like is in you push it in and it sort of grabs the castellated edges, that kind of a way. But one can dream.
I found like a bag, like a 2 millimeter high female headers. But the only way you could buy them was in packs of 500. I really need them. I really want to have them. So now I use them in everything because I had it of them. Yeah. So basically, that's what I'm working on, and of course, ongoing independently from that is still working on all the games for it. Like I have Tetris, I have Snake, I have Sokoban, I have Digger. What else? Breakout. All the classics that you can do in 8x8 pixels. Oh, there is also Reversi that a friend wrote, and there is a 3D game, first-person perspective game, where you have a labyrinth and you explore a labyrinth. He actually did ray tracing. And the amazing thing is that if you only have 8 pixels, like 8 columns of pixels, you can really do the ray tracing very fast. Because you only need to cast like 8 rays. And it works really nicely.
Cool.
Yeah, answering the questions from the chat. Yes, you will be able to buy this. No, I don't know why, when, and for how much.
I think people were asking about the cardboard one, if they could buy the cardboard.
It literally wants the actual cardboard one.
Well, if we meet on some maker fair or something like that. Oh, hi, Christian. So Christian is the person who wrote the Reversi and the 3D game. He also made his own version of this shield that works on Sion's tiny Pico boards. So it's really nice. I really like how it became a bit of an open environment and not just a single project. Like there are versions that run on MicroPython, on CircuitPython, so on. So yeah.
By the way, while you were talking, I bought one from MakerFabs. So it was worth it. This advertisement was worth it for that one sale.
I hope you will be happy with it.
I'm sure it will be very happy in my dev board graveyard with all the rest of them. I do want to learn CircuitPython at some stage, and I think it's the perfect board for it. So I'll have no excuse when it arrives.
Oh, one more thing. It has like all the pins I didn't use. It has them broken out here.
Nice.
And the holes are staggered, so you can actually insert a mail header in there without soldering and plug it into a breadboard, like on the edge of the breadboard.
Nice.
So you can do also some LED blinking stuff and so on. And it has USB heat support, so you can make it like a gamepad or out of it. And,
really cool. Looking
you
forward
really
to it.
think of everything. It's amazing. It's also every time you're on the MakerCast, you have so much stuff to show. I'm always amazed by that.
I just keep reusing the same things.
No, it's really cool. So these are really cool projects, definitely. Nice. Okay. So, Timon, how about you?
Yeah, sure. I don't have that much this time, so hopefully I'll be quick. Some of you maybe seen it already. I found these RGB ring lights on AliExpress. And the cool thing about these is they are not actually just, one light. They actually have a pixel array in here. So it's like NeoPixels and really nice form factor. And I opened the controller up for that, which comes in this little box with a few buttons. And that doesn't focus. Come on. There we go. And I didn't really like the presets in there. It comes with some animations and stuff like that. And I thought maybe it would be nice to put your own microcontroller in here. And here's so this was in there before. It was the original controller that I removed from this. I have no idea what the controller this was. But yeah, these are pretty generic boards, and you can see it has 3 outputs essentially. So like one for the pixels, and then warm white and cool white LEDs. So yeah, you get quite the range of colors from this. And I thought it would be fun to add a different controller in here, and I'll do the stupid thing and open this up before I show it to you. I actually found out that the new Raspberry Pi Pico fits pretty perfectly in here. And I made a little add-on board for that. And the funny part was that, if this focuses again, you can see these 2 little holes next to the USB port. They fit perfectly on these 2 pegs of this case here. No, not my face, please, the case, yeah. They exactly the same spacing. So that just pops over here. And yeah, the whole thing just fits in the original case, which was quite cool. And I made a little PCB to replace the old buttons and 2 MOSFETs to control the dumb LEDs, the white ones and the warm white ones. And that's pretty much it. And then I cut a bit of a hole in the front so I can actually access the micro USB port. And now the whole thing is controllable via CircuitPython. And I can quickly show you that. I'll plug it in. And this doesn't show on camera very well if I point it directly towards it. So I turn off my lights here. And usually it works best by reflecting on a surface like my face. So if I put my microphone away, you can see the rainbow animation.
This looks actually pretty cool. I like this effect.
Yeah, it is a cool effect, right? And it's like very sci-fi.
We can see it in your eyes.
And if I press the button, I switch my mode. And this is all running, CircuitPython. So it's really quickly, you can change animations or change the behavior of these buttons.
I would have not expected this to look like this. This is pretty cool.
And it's a really surprisingly good build quality too. Like, there are different versions. So this is a slightly pricier one that cost me 18 euros. But shipping from Germany actually, so a little bit of markup there too. And I guess I can quickly show you code for this too. Just show you how quick that is to change this. If I share my screen. Yeah, you can exactly. So you can also, of course, control the white LEDs. So if I call it the rainbow, it starts to pulse the white light. And I think it's quite cool for like filmmaking too. Like, you can really do some really cool animations for your shots. It's really cheap thing, and you have like your camera mount with a nice threaded insert and stuff like that. So it's really easy to integrate that. That's the project. Other than that, I don't want to talk too much about it just yet because I'm close to finishing that up. But on the last MakerCast, let me turn the light off here, and my normal one's back on. I showed you, which was initially a little weekend project, but turned out into a little bit of a larger thing. This is my Raspberry Pi CM4 carrier called Pionora. And I showed that like a sneak peek of that in December on MakerCast. And since then I founded a company called Diet's Delight. And launching this through soonish through Crowd Supply. And hopefully more on that on the next MakerCast. But this is the latest revision. And I guess I talked last time length about this, but essentially Compute Module 4, Raspberry Pi Module 4 with an ADC in an Arduino form factor, USB, HDMI, all the fancy stuff, STEMMA QT. And on the back, but not mounted on this revision right now, is also PCI Express with an M2 form factor and a full-size camera port over here. The newest revision is in post, but stuck in customs because German customs are currently completely in turmoil. So I don't know when I will get those. But once I have those and verified those, you can hopefully eventually buy these on Crowd Supply.
Is that M.2 slot just directly connected to the PCIe, or is there something in between?
In this case, not. Usually you need AC coupling capacitors for PCI Express. I'm not sure why the Pi wouldn't need them, but I just basically went by whatever Raspberry Pi recommends. It's usually best to go what the manufacturer says. But normally you would have coupling capacitors in there to remove any DC offset bias you could have. But it's straightforward. It's not much there.
I need to learn about that one.
It's not hard. I can help you. Don't worry. All right. Maybe one little thing I worked to get. I don't know if it's too makerish, but maybe some of you know the Glasgow, which is a project by Aston. And I made that little aluminium case for him for his Crowd Supply campaign that launched back in January or February. I'm not sure now. That came out quite nice.
I thought it was super cool that this Pionora thing has mirrored logo, and now I notice that everything you show is mirrored.
I've maybe mirrored because my brain gets confused if I don't, and then I'm showing stuff always in the wrong direction.
Some parts look normal to me, and I got confused by that as well. So I think the main part of the LED ring was that you found these cheap ones, right? But I was thinking whether this would, like the effect that you showed on with the colors on your face, how this would look with a larger ring or something. I was wondering how that, because that looked really cool. You mentioned
Yeah, with like a
filmmaking.
very dense LED strip, you could probably do something similar.
Yeah. Yeah.
So there is one technique that is used in some computer games where they basically take a two-dimensional image and make like a haze map, like the lighting map, by using three different colors. Like you shine three different colors from the three different ways, and then by manipulating the palette, you basically can make it be can control where the light is on the thing being displayed, and this strikes me as a good way of making like assets for such a game if you want to try this technique.
Right. So you mean like a normal map, or?
Yeah, something like that. It's basically in RGB you encode the direction of the light instead of the color of the light.
Right. Yeah, it would be fun to try that.
Cool. So, any more questions? Anything else to add?
Timon, I just bought one of those too. I need to stop listening to this. I
Alright,
probably could have just
I
got
forgot to upload the files so far. I'm really slacking on that, but that will happen soon.
Welcome to the shopping cast.
Yeah, that's fine. Like I'll probably never get to this one either. But you know those
they actually do quite good studio lights too. You don't have to hack them.
You know those Pixel Purse toys that were doing the rounds a couple of years ago? I bought one of those to take the Matrix out. Still in rotation as a kid's toy, like at the moment. Like I just never got around to it. So I could see the same thing happening here too, where I just like, I'll start using this and not hack it at all.
Cool. Okay. So, well, that leaves me, I guess. Let me see. Can I make my pick? Why can't I go directly in a larger picture like this? Yeah, you've probably seen my project in the background already. Last month, I upgraded my 3D printer with a 3D printed gripper so that it could play chess. Let's see, can we get this to focus here? Yes, we can. Nice. And maybe we'll make it a little bit brighter as well so you can see it better. Yeah, so I actually already as a teenager, I was thinking about building a chess robot that I could play chess against, even though I'm really bad at chess. But yeah, recently, like last month, I thought, well, I have this 3D printer which can move its printhead very precisely. So if we could attach something on there to grip things, that would be kind of cool. And well, yeah, that's what I did. And this was a really fun project. So what this printer actually does, so this is a whole chess game. How it works is we have the webcam in the top here. So you can see here on top I mounted a webcam with some clamps to the filament spool holder up here. And this is connected to a Raspberry Pi that runs Octoprint in the back. So this is what pretty much my normal setup for the 3D printer, except that I usually don't have the webcam mounted up here, but it's lying somewhere else so I can monitor the print through Octopi or Octoprint. And yes, but up here it sees the board from top-down perspective. And on my laptop I wrote some Python code that plays chess with me. Actually, my wife helped me with this, so she wrote the part that does the computer vision. So she detects the board, and after detecting the board, we can tell it to detect the human move, and it will monitor for moves, and once everything calms down and there's no movement anymore, it will try to find out which move was done in here. And this works really well. I was surprised how well this works. So if I make a move, it would detect that. It's not running at the moment, but it would detect that. And then I used an open source chess AI to determine the next move, and then the moves get sent back to Octoprint. So I use the Octoprint REST API to move the print head around. And as you can see, so this is an Ender 3 3D printer, and the stock version doesn't have the direct drive extruder. I recently got the direct drive extruder, which enabled me to pretty easily mount this gripper up here. So I'm not sure if we can make this visible on the stream. Let's see if I can get this to refocus. Hello? Focus.
Oh, that's a really smart. It's a
yes.
cable basically, instead of.
Yeah, it's pretty simple. So there's just a thread here that which goes around, and then in the end, behind here, I have attached this to the extruder motor, and yeah, so closing this is just an extrusion command, and opening it is just retracting again. Of course, you shouldn't have any filament in there because I'm not heating up the nozzle, so actually it might work. So if it just goes, I think 5 millimeters in and out to close and open this gripper thing up here. So yeah, that was pretty fun. I'm not sure if I should turn it on because it is quite loud because of the extruder fan here. I have to turn it on. Okay.
Right?
Okay. We'll try if we can get it to work. So let's turn on the printer itself. Let's refocus here. Maybe zoom in. Oops, that's not what I wanted to do. Zoom in a little bit more so you can actually see what it's doing. Okay, it's actually not too loud. Or how does it sound for you?
It's fine.
Picking
yeah,
it
it's okay. It's not a.
That's the wrong way. Okay, so what I have to do first is go into Octoprint, and I won't show that on stream right now, but I can describe it for you. So Octoprint, for people who don't know it, is a software that you can interface with your 3D printer, and it's pretty much a more convenient interface than the little screen and knob of the printer itself. And in here, I also have a terminal where I can send it G-code. So G-code are the commands that tell the 3D printer what to do. And I first have to enable cold extrusion because normally the printer has a protection mechanism that won't allow it to use the extruder motor if the nozzle is cold, because if the nozzle is cold, it would normally not be able to extrude filament. So I have to enable that. I actually had to change my firmware to incorporate that because my firmware did not have that. And then we also need to home the printer or the print head because it needs to know. So we need to have it homed first. The printer needs to know its position and coordinates.
So Matou, this would print again if you just took off the head, right? And
yeah, I've printed in between. So last week or this week I have actually printed stuff. So it's fairly quick. The chessboard, I've printed that directly on the print bed. But after the video, I have removed the chessboard, and now it's just laying on there with some clamps in the back, so it doesn't move around too much. So this is fairly quickly to to change back to a regular 3D printer. That was one of my goals. So that's also why this fan, I don't really need this fan because that cools the nozzle, and I wouldn't need that. But there's no software switch or there's no G-code or anything to turn it off. I would have to unplug it, and I really couldn't bother, or I really didn't bother with doing that. I was thinking about installing a switch or something so I could do that manually. But yeah, so Bitloon is actually asking, and I thought about this, if I got a second setup like this, I could play with a friend remotely during lockdown. And I actually thought about this. I mean, you wouldn't even need a second one. You could, like, the other person could play with a regular chess software, and one of us could have the 3D printer. Okay, so let's see.
Could you set it up so that it plays itself?
Yeah, it can play itself as well. I was thinking about doing that as a part of the video, but
that would be really cool to have a time lapse of it playing itself. That would be really fun to watch. I think.
I thought about doing that as the end, as the end part of the video, but So, but that's actually an idea. I could do that and publish a video maybe on, I don't know, like you say, a time lapse of it playing itself. Would be pretty cool. Yeah. So during the homing command, so when the printhead homes itself, the pieces tend to get thrown around a bit. So now it's in its parking position. So I've put the parking position on the right side. Remember, the webcam is in the middle up here. So this parking is pretty much out of the way of the webcam. And to get it moving, let's see if it works. I haven't really calibrated that very well, but let's see if we can get it to make a move. Yeah, let's see what it does.
So tense. Yes.
Oh, no. It almost worked. Okay. Yeah. I think we can easily fix that. It looks like it didn't close a lot, so I probably either the string loosened a little bit while I was touching it earlier, or I didn't calibrate it correctly. So I can easily fix it by extruding it for a millimeter now. And let's just try it again, and then it should work. And once I got this working, I actually played some games against it. I was surprised how reliable it was and how well it worked. So there we go.
Nice.
There we go. Yeah, I used this chess set. I took the inspiration from the Bauhaus design. So the Bauhaus art school has a very, very similar kind of chess set because it's all more or less cubes, so it's easy to it's super easy to grip this with this kind of gripper, and the pawns are just a little bit smaller cubes, so I just had to adjust how far the gripper closes for moving pawns, other than moving regular chess pieces. And yeah, so that was my project last month, and this one was pretty fun one.
I love this. Yeah, I had plans, like I have a bazillion plans to do loads of stuff to do this as well, and I was thinking about using an electromagnet on the head, but like I think that works nicely because I would have had to basically make it not a 3D printer anymore. And I actually held on to an old 3D printer almost just for that job. But yeah, like I think this is great.
Yeah, I'm quite satisfied that I can change it quickly back to a regular 3D printer and just switch it around, and yeah,
that's very smart design.
I have I have to ask this. Are you going to sell keeps?
So, sorry. Oh, if I'm going to sell this,
Yeah,
or
to
what
sell
was the
keeps.
question? Oh, kits. Oh, yeah. Well, I've uploaded the files on my GitHub page. So in the video, it's yeah, those are available. Of course, that's very specialized for my setup here. So I have no idea how repeatable that would be with this extruder. So I had to measure a lot, and I had quite a few prototypes to make this fit this exact setup that I have here.
It's
Every person who wanted to get it already has a 3D printer, I suppose.
Yeah.
I think like it'd work. Like the same concept would work with the Bowden extruder too, right? You just bring the string further back, right, and just attach it to the motor further away, right? It wouldn't, or you might have some problems with how it would move.
I'm
I
not
guess.
sure if it would pull on the string if it moved around. I wasn't sure about that. So
The thing with a Bowden system is when the tube is fixed, it will move it accordingly. When the tube can move, it will not do it accordingly. That's the mechanical principle behind a Bowden tube. So that should work if your tube doesn't differ in length or is
Yeah,
not mounted
you could
correctly.
even use not a string, but use the filament itself.
Ooh.
yeah, that I like the idea. Was it your comment? I know, like attaching it to the filament itself. I like this idea. That could work actually.
So what happens when you take a piece? Like, how does it deal with two pieces trying to be in the same square?
So you mean if I capture a piece?
Yeah. Or like, what
Or
if
if the
it
printer
captured?
captures.
Like, if the printer captures a piece, how does it
Oh yeah.
handle that?
If actually, well, I switched it off already. But so it throws it outside. So it throws the captured piece outside the board before it. Does
So
that. I
it
think-
Joe picks up the piece it's going to capture, throws it away, and then
Yeah.
sets the new piece in the place.
Yeah,
That's an ultimate
so
power
it
move.
takes this
That's
and
awesome.
drops it here in the 0 position for X and Y. So it just drops it here, and then it sets its own piece instead of it.
That's awesome.
Yeah.
So
All right.
the camera, is it
Yeah.
does it do essentially one move and then stop, take a picture of the board, and then calculate what the next best move is after that? Or does it have like some form of move history that it looks at and knows where its pieces are?
Yeah, those are all independent modules. So we've pretty much. So I use I think it's called Sunfish Chess AI. It's open source, written in Python, and that keeps the history of the board and the board status and everything. So it's pretty much just a string of characters that tells the tool what the board looks like and which moves have been made so far. So it has the history. I'm not sure how much of it uses. I just interfaced with that, and what I pretty much do, I plugged in usually you type your move on the terminal with your keyboard and just tell it, okay, you type A3 B3 or something to move from A3 to B3, and instead of doing that, we plugged in our computer vision module that first waits until it sees that something has changed, then it tries to figure out what changed, and then it outputs this string instead. So this will tell the chess AI what move happened, and then that will again output a string, and then I parse that and translate that into commands for Octoprint, which I send over the network to the REST API of Octoprint.
That's really cool, man. That's awesome.
Thanks. Yeah, it was a really fun project. All right, so we didn't forget anyone, right? No, I think everyone was talking about their projects, which is pretty cool. So we're coming towards the end of the MakerCast, but I heard a rumor that people were asking for a quiz. And I mean, we've already 2 hours in, but I think maybe we have time for a short round of a little bit of a game. So it's not exactly, I'm not sure if we can call this a quiz. I want to play a round of Sketchful.io with you, and the guests have been warned before. This is a very simple game, a drawing game. So one person can choose from a list of words and has to draw that word, and the other people have to guess. And people get points for guessing correctly, and people get points if they are drawing and people guessed they are drawing correctly. And since it's the MakerCast, I asked a good friend to compile a list of maker words for me, and I actually managed to not get spoilered, I think. Yeah, so I think I managed that. So because so I have a list here that I uploaded here, the file, and on top of the field that shows the words, I put a window that is always on top, so I wouldn't see it myself, because somehow, somehow this will be visible otherwise. So I managed to not see the words so far, and most of us are already in the lobby here. I will also share my screen in a moment, but I will have to wait until we start the game, because currently the words would be visible. Okay, so we have Timon, David, and deshipu are here. I'm not sure about Clem and Brian.
I have no idea where I should go.
Oh, you put it in the private chat.
There's a window.
Okay.
Right, so in the StreamYard, I put a link in the private chat, and when you click that, you might also have to click on the banner on the top to join the room.
Okay.
And okay, so minimum is 2 rounds. Well, let's try it, I guess. I think we're all here, so who's Hilarious Starfish? So that would be
I think it's Clem.
Clem, I think, yeah. Perfect. Okay, I have streamer mode enabled, so you won't see my words in the stream when it's my turn. So I guess we'll just try it. And if I'm first, I'm gonna panic because I have to do that at the same time as sharing my screen. Okay. Oh, of course it's me. Yeah, of course it's me. Well, okay, I quickly try to share my screen. And if not, we'll just start with the next person. Where's the game? This one, I think. Oh gosh, I hope I'm not sharing.
You're
Yes,
sharing
I'm playing.
everything.
I hope I'm not sharing the words.
People will flat this like
There
a
we go. There we go. Okay, so I'll start drawing now, so you can actually
bucket.
guess. You have to write that in the chat.
Oh god.
You have to write the things in the chat. Oh gosh, I'm so bad at this. Remember, this is all making related stuff, so
What? Oh.
I should have
Resin.
write that in the chat.
Well, it's no fair if everybody says it out loud.
Yeah,
You
exactly.
should do
Don't
that.
say it out loud.
Sorry.
I would
so
not have
think
guessed
people
it if
got that
Brian didn't say
already.
it.
Yeah,
I didn't say
heard.
anything.
That makes it-
Did we already guess that thing?
Hilarious Starfish didn't type it in.
Yeah, you didn't type it in yet. You have to type it in.
Huh?
Perfect. Cool.
I also want to address the slander that I said the word out loud. I did not.
No,
I'm ultra competitive. I would not give you any advantage.
Oh,
Oh man, this one's 2 words. All right.
We can see your guesses, Matteo. I just won't look.
Oh, you can see my guesses. Yeah, right. Yeah, don't look at. Well, you can see the correct guess.
Yeah. Hilarious fish gave me that one.
You just didn't have the space.
oh my God.
Whoa, whoa, that's that's 3 words. Wow.
Oh, jeez.
Butter, butter,
Okay.
butter, butter.
But yeah, I think it doesn't. Okay.
Green square. Green screen.
I actually have no idea.
Oh, jeez. Okay. Oh, jeez. Okay.
Oh. It's so hard to type.
Ah,
I got it.
I always lose at these games because I'm just so slow to type.
That's a good drawing, though.
That was a really, really good drawing. Yeah.
Yeah, that was.
The colors make a huge difference.
Yeah, totally.
Yeah, absolutely. Yeah, I wish I could abbreviate it PCB, but that doesn't work here.
This guy's going 3-dimensional. That's amazing.
Yeah,
I still
it's so
don't have a clue what it is, though.
oh my God.
That word doesn't come into my mind. Oh, God damn it.
Oh, yeah.
That is the best drawing I've ever seen.
That's amazing.
Wow.
That's phenomenal. We have an artist in the midst.
Wow.
Jesus.
I could even tell you the
that's
I
brand.
made the circle, but I
Yeah.
could not remember the name of the thing.
That's phenomenal. I could not have done that.
I'm
You-
so
you.
worried about my turn. You will not see
Do
this.
you?
The cable even has 3 dimensions. What's this about?
Somebody hasn't guessed. It's Matteo.
Matou.
Yeah, it's me. I still have actually. I'm
You still have
don't
no
know.
clue
was
what it is.
Oh, of course. Okay, I was thinking in totally wrong dimensions. I thought this was like a table and a machine type of thing. Yeah. Okay, it was a really good drawing.
Wait, what? 2 letters at the end, okay. Printer 3D. What?
How did you get that?
It's amazing.
Obvious.
They should guess the word. Is it obvious?
I don't find it obvious. Oh,
I haven't got a clue. This is crazy.
I mean,
Somebody else guessed the word. I get it.
Okay, all right.
I can't spell that word.
Problem now.
Oh,
the chat is also
know the word.
wondering.
wait. What did? Oh, I forgot the B. Damn it.
It always trips me up writing stuff for and then leaking it.
I'll give you a little bit of treaty.
Desk.
Box nailed it.
Oh. Yes, nice one.
Oh,
Cyberdeck. Yes.
I got it.
I have no clue how to write that in English.
The question is how to spell
Yeah, I
it.
was really
It's hard to
afraid I
spell.
would-
Yeah.
yeah.
that's
That's the
autocorrect.
tricky part.
Autocorrect for the
The other ones weren't very good maker ones, but I was like, this one's so hard to spell.
Yeah. Oh, second round. Okay, I have to. Oh yes. Let's try. Let's try that. Okay, how do I draw this?
That's a game actually worth streaming.
For sure.
Yeah.
Nunchuck.
Make a Twitch channel.
Something I won't name on stream. Pants. It doesn't really get more family friendly.
Yeah, everything I can think of is not safe work.
Oh gosh. Okay, I guess my drawing
Timon
isn't the
got it.
best one.
Huh?
Wait, we can add something here.
Uh-huh.
Oh gosh, I'm sorry.
I need the
It's
first
I
one.
find it quite obvious.
People in the chat got it.
Oh, come on. Now I'm looking at the chat.
I'm terrible at.
How
like,
in the
I don't-
world is that a hairdryer?
Oh! Can I,
I
get
don't
it?
know if I'm-
Oh man, I was typing it in.
Angle triangle.
I don't know if I'm dyslexic. I just cannot figure words like from missing words or missing letters.
Yeah, it's hard. I completely relate to that.
Baby bottle.
Yeah, that's exactly what I was thinking. I was trying to figure out how that was maker related.
Well,
My guess was
new
redacted
makers
because
in
of
the
profanity.
Hey, I got it. Hooray.
nice. Ooh, nice.
Was it cheating? I don't know. But in France.
Ooh.
Okay, here we go.
What? How did you guess that, Brian?
I'm a genius.
How do you undo?
Whoa, what happened?
What?
There we go.
Wait,
I don't really know what to add to this.
Well, I knew it, but I don't.
We were using spray paint earlier today.
Oh, spray paint.
It's on my mind.
Camel. Garbage. Gun.
Is that a candle garbage gun? Is that a new tool that I don't know about?
Yeah.
It's
Exactly
cool.
that one.
Every maker needs that, yeah.
table thing.
Okay. Okay.
Wait, what?
I have no sense of scale. Like, is this something that sits on the table?
But
Yes.
Clem guessed it. What is that?
I know exactly which
Okay,
model
okay.
you're
Oh,
referring
God.
to. With that.
Yay!
Oh, I was slow.
That's one of those old, like, foot-powered ones, too.
That's a Singer
Yeah,
sewing
it's a
machine.
Singer.
Yeah, an old
Sorry.
singer.
Oh, I'm choosing a word. I have no idea how to draw that.
That's what's going to start.
Oh, that's a short word.
That's
Oh, Bruce too long already.
Okay. Now it's for the quick typing around.
I see. Okay,
That's
that was
cheating.
surprisingly difficult for.
Wait, what? What?
Is that not cheating?
Yeah, it's totally
It's
cheating.
incredibly
writing the
cheating.
thing. Totally cheating writing that one.
I don't know how you draw that though.
Yeah, I should have drawn it from the inside.
What is a Fab Lab
Yeah,
though?
that's a-
What?
The same like a makerspace, but fancy.
Okay.
But fancy.
Fabrication laboratory.
What?
How?
Oh, what's it called?
Oh.
Is it the taser from Star Trek?
Maybe.
It's a toe hammer.
So,
Got it.
that also make it worse.
Earwax remover.
That was the slowest.
Oh man, deshipu is.
Deshipu
yeah.
killed it.
Deshipu's king.
Droid.
All right,
I
nice.
thought I went all right.
Well,
That was-
thank you
that was
everyone
fun.
for playing with me.
That was
Yeah, I can prepare.
Nice, man.
Oh, you came! Whoa, you came with a
No wonder
good
you were
one.
able to.
Pro.
Nice.
That servo was a work of art.
Amazing.
Yeah, that was
yeah.
good. That was really good.
I didn't know what it was until you started drawing the tab, for mounting it. I was like, oh man, I know exactly what that is now.
Cool. Yeah. So that was the quiz for tonight. Nice, nice. So, well, thanks everyone for joining the MakerCast this month. That was a really fun round today. I enjoyed that. I enjoyed hosting it. Sorry for sometimes choosing the wrong people to be in the large screen.
I think that's more on StreamYard than it is on you.
I think it is actually. I couldn't figure out if there's a control to select which. Like I can click each person to become the only visible video, but I like in this other view where the other people are on the right, I couldn't choose directly which one. I first had to switch to that view and then pull persons around. That was interesting. But anyway, I really liked it. You have really cool projects working on. So yeah, if people would like to check out your projects, I've put links to your Twitters, your YouTubes in the video description of this stream. So you can check that out here. If I've forgotten something, just ping me and I will update it. Yeah, just let me know if I overlooked something, if I've forgotten something. And I'd say that's it for this month's MakerCast. And I actually don't know who's hosting next month. I forgot to check that. Do we know that
is
already?
Probably. I think. Let's see.
So,
Oh, see him.
okay. Yeah, well, we'll let you know. To find out, and most definitely, you can simply follow @TheMakerCast on Twitter. That will definitely tell you on time.
And
who
we also
will
have a
be-
newsletter.
Yep, we also have a newsletter. I actually also don't know where to find that, and I don't have that. in the
It's
description, so we'll have-
tinyletter.com/makercast.
Okay, nice, cool.
Awesome.
And we also have a playlist of all previous MakerCasts that is also linked in the description. So if you want to find that, you can watch all of the previous MakerCasts with all of the other amazing makers, and new MakerCasts will be added there as well. So if you don't have the time to catch this live, you can always watch the recordings. Cool. Okay, so bye-bye everyone, and thanks all you makers who joined me tonight, and
Goodbye.
bye everyone who is watching the stream. See you next time.